I am Stanley Fahn, and today I'm interviewing Dr. Serge Przedborski, who will be giving the David Marsden Lecture this year. Today is Sunday, June 5th, 2011, and this is the 15th Congress of the Movement Disorder Society. So let me start out, and by the way, I should say we're also in Toronto, Canada. So let me start out, Serge, and first of all, congratulating you. I think that's a great honor. You have a number of predecessors who are in front of you who are outstanding people, so you're joining that class. So I'm sure you feel pretty good about it.
Oh, it's absolutely a huge honor for me, for many reasons. One, it's of course to join this group of very impressive people who I look to for so many years, but also, as you know, David has been, for many of us, and still for me, really a leader and someone that, and certainly at Colombia in your group, we were very attached to him, and so it's such a honor to be able to deliver this year's lecture, particularly in the context of the David Marsden name lecture. It means a lot to me.
Well, congratulations again. I'm going to come back to that because I want to hear more about what you're going to say and so forth, but I thought we should start our interview by asking you something about your background. First of all, I'm going to ask you about your name. I've learned over the years I've been pronouncing it incorrectly because it starts with PRZ, and I've been calling you Przedborski, and you never corrected me. And then one day I learned it was Przedborski because it's Polish.
That's right.
Tell us about your name and how do you feel when other people don't know how to pronounce it?
Well, I guess that since I also needed something like now 50 years to learn how to say it properly, I would certainly not blame anyone to have difficulty with that name. But it's true, it's a Polish name, and in fact the major difficulty is that if you look how it's written, then it becomes impossible to pronounce because it really corresponds to a succession of letters that correspond in Polish apparently to a specific phoneme, to a certain sound. So Polish people immediately recognize it, we don't. And among other things is this R that it's in between everything, that it's impossible. And so if you want to pronounce it in a phonetic manner, it will be P-C-H-E-D, and then Borski, it's easy. So it's Przedborski.
I see. Okay, so you got used to how people, and they still to this day, I know some people call you Przedborski.
And most of my patients will call me Dr. Serge.
Yes, well, that's also easier. So tell me, you have a Polish name, but you come from Belgium. Tell me a little bit about your background.
So basically, yes, indeed. My parents are Polish of origin. They came, and particularly my father came to Belgium as an orphan of war, and basically that's where he met my mother. I'm born in Belgium, but soon after that I went to France. I did all my schooling in France, and then after high school, basically I thought that I wanted to go to medical school, and I thought there was a good opportunity maybe to change a little bit horizon, and why not to go and learn a little bit about Belgium, the country where I was born, but I did not know so well at all. And so I went to do my medical school in Belgium, and I liked it, and then the residency, and then I did a little bit, I started research, and from then I moved to New York.
Right. Well, I remember when you came to New York, you wanted a fellowship in movement disorders.
Absolutely.
And in that you wanted to have both clinical and basic science training. And so we accepted you at that time, and you did some work in the clinic and also spent time in the lab. And
That's right.
I remember your first project was an animal model of some dyskinesias, and you wrote up the abstract, and I think it was presented at an international meeting as a poster. And I know that you won the prize for the best basic science poster.
That's right.
Do you remember those studies?
Oh, absolutely. So basically, at that time, when I came to join your group, I had a major interest, and I've done some work in the past in receptor studies and what we call in the jargon the binding autoradiography. And I was basically, when I joined your group, I was using this technique to study some of the chemical neuroanatomy of the basal ganglia by putting some emphasis on the receptor specifically. And what I found was an alteration in the interpeduncular nucleus, reduction of 5-HT1A receptor, which of course at the time was a big push for the serotonergic system in dyskinesias and other dystonia and other movement disorder. And so that was quite exciting findings. But indeed, at this point, that was very descriptive. I didn't have access to molecular means to really show the mechanistic aspect of this finding. But receptor-wise and I would say descriptive-wise, yes, that was a very nice study, and I really had a great time. And clearly, I think that Dr. Grabel was one of the member of the panel who awarded me the first prize, and she was very excited to see the image that I showed at this meeting. Indeed.
Right. And was it that kind of work that just made you decide that you really wanted to have a career in laboratory research?
Oh, absolutely. In fact, I always, to some extent, I think that for me, research always been a way that you could satisfy fully the questions, your curiosity, whether it's clinical research or basic research. And I believe that that's probably also why I was drawn or interested in neurology at the first place, because I always saw that in medicines, and probably there are other disciplines, but I really fell in love with neurology because of this combined clinical contact, but also the complexity of neurology and the fact that if you really want to approach neurology in an analytic manner or ask yourself questions, it's endless. Sky is the limit. And I thought that was really exciting. And along this line, meeting with some people that really influence, I think, my career development, including yourself and David and Ivagid and Jerzy Hildebrand in Belgium, really I begin to realize that clinical is one thing, but you can still be a clinician and ask this question and do some basic research. And that really, when I came to the United States at Colombia, that was my first contact to the reality that in fact there is such a job that exists, and that it's called clinician scientist, which in Europe, from where I'm coming, they didn't have that at that point. Now, of course, things have changed. And I thought that was really the top of what an academician can do. And so, yes, indeed, that was a big eye-opening for me.
So you mentioned that was one of the attractions that led you into neurology, but what led you to go into movement disorders?
Well, to some extent, it's the same thing. Very soon, when I started to be interested in neurology and started to be interested in trying to bridge clinical and basic science work, I also realized that movement disorder was, to me, an amazing field where bridging, I would say, from bench to bedside was so natural. And honestly, this, what we call today translational neuroscience, that include both clinical research and basic research, seems for our junior colleagues now absolutely normal or natural. At that time was not. And I thought movement disorder was really so exciting. You have to remember that when I came and began to work under your mentoring, that was really the time that you had this explosion of the chemical neuroanatomy of the basal ganglia with all these new models that were proposed how to explain based on the unbalance between the direct and indirect pathways, the abnormal movements that we see, etc. There was all this explosion of the MPTP and the mitochondrial aspects of pathogenesis that were really becoming to be center stage. And for me was how seeing the patient and all this phenomenology that you were teaching us and that we were seeing every day in clinic how can you use that to try to understand and think about chemical neuroanatomy, physiopathology, and pathogenesis? And that, I thought that was fantastic.
So what year was it that you actually came and started your movement disorder fellowship with us? Do you remember the year?
Yes, absolutely. I arrived in October of '88.
Okay. And you just right away wanted to get into the lab. You told me that, and we assigned you to the lab as well as working in the clinic, and you spent 2 years with us. But then you had to go back to Belgium.
Absolutely, because if you remember, Belgium at that time, at least, had still mandatory military duties, and it was this dramatic time that was the first Gulf War started, and they needed Belgium. Basically, was part of the coalition, and what Belgium was offering to provide to the coalition was mainly medical support. And so I had to go back to, because my time to go to the military service plus this situation made such that I had to go back. And I spent basically, I think, 8 months or something like that in Belgium for my duties. And after that, I applied to a faculty position in the department, and I remember that one day I was in Belgium working on some paper. I don't remember exactly what paper was that, but and I was told that I was given the junior faculty position. Will I be interested to take it, and when can I start? And I remember that I was not sure whether that was a joke or something, and of course I was delighted, and I didn't jump on the first plane, but I think maybe on the second one.
Okay, let me go back again. Also, you got interested in movement disorders because while you were still a neurology resident, but of all the places in the world to do your training, why did you ask to come to Colombia, or is it because no one else would take you and we ended up with us?
Absolutely, that was it. No. In fact, I applied to different places, and if you remember, at that point, really the two, and I'm not saying that there were not maybe other great programs already at the time, but the two that had this really kind of integrated program at our time, they were two, and maybe a third one. There was La Salpêtrière, Queen Square was David Marsden's group, and Colombia was you. And basically, that's where I think that Dr. Hildebrand, the chair of neurology, where I was training, really played a very important role in my decision, in the sense that he was a strong believer that at some point, if you want to make an experience like this, you really have, of course, everything being equal. If the quality of the different places were the same, which I'm not saying that they were, but if they were the same, you had to put some distance between you and your new training. In other words, that you had to cut the umbilical cord. And he trained in part at Harvard in Boston, and so he thought that I had to go to the United States, and a place like Colombia was so spectacular that for him it was a no-brainer, that he encouraged me and advised me to pursue contact with you and to join your group. Okay,
so we knew how good you were in the lab as a fellow. You had to go back to Belgium for the military service. And also, I think, to get your visa and everything else had to be changed. And so we had to wait for that. But then you came back, you joined us, and we gave you a lab at Colombia. And you started to do your own research. And what did you decide to do? Because you were no longer going to work on that animal model earlier, but you switched a little bit into another field.
Right. So at that time, I was already starting, by the end of my fellowship at Colombia, I was already starting to try to find basically what really excited me the most in everything that I was doing or trying to do. And of course that was not easy, because there was a lot of things that I was excited to do at that time, and still now. And basically what really attract my attention, because I always had a lot of interest in molecular and cellular biology, was to look in mitochondria. And if you remember at that point, by the end of my training as a fellow at Colombia, that was really the beginning of the idea that perhaps a bioenergetic defect in mitochondria could be central to the pathogenesis of Parkinson's disease. And I remember that you basically organized for me meetings with, we were fortunate at Colombia and to have really leading figure in the mitochondrial field with the group of Salvatore Di Moro, Eric Schoen, and Michio Irano at the Merit Center. And we had this meeting, I remember, that you organized for the movement disorder group and as well as for me, to meet with the mitochondrial group at Colombia. And the question was how we can approach that. And I started to work a little bit with Dr. Di Moro, if you remember, learning about mitochondrial biology. And I really fell in love for this aspect. And of course, at that time, bioenergetic, and who said bioenergetic and respiration of mitochondria led to MPTP, which again, at that time was the prevalent idea about how perhaps Parkinson could be, or Parkinsonism could be caused by a mitochondrial defect like this. And I did for many years. I developed an expertise in MPTP, and I think that one of the things that I have tried to bring to the MPTP field was to try to look into these toxins from a molecular point of view, not so much as a descriptive, which has been done a lot before I started, but more on the molecular, how the toxin works, how it's activated, what can we learn, is there anything that we can learn from this that will give us some insight into the neurobiology of Parkinson's disease, and or maybe help us to devise therapies. And so that was, I would say, my first independent direction of research.
Right. You did a lot of work in that field with MPTP. You were probably, I would think, one of the leading people in the world working on the molecular aspects of how MPTP can cause degeneration of the nigral neurons, dopamine neurons. And so I think your career really took off. You got noticed by a lot of people. And you continue to work in this field, and you still do some MPT work.
Absolutely.
But you've spread out. Now you're doing other things as well, including a lot of stuff, genetics and how genes are affecting Parkinson's and so forth. And you might want to tell us about some of that.
So absolutely. So basically, and that would be basically the theme of my presentation for the David Marsden lecture, is that really there have been a kind of very interesting roller coaster ride for the mitochondrial field in Parkinson's disease and neurodegeneration in general when it comes to adult onset neurodegeneration. And for Parkinson's disease particularly, you had the phase where you had first the bioenergetic, that's in the 80s, then after that the MPTP, the rotenone, and then a little bit of less enthusiasm until basically some new findings came along. First of all, it was discovered that mitochondria are the repository of key death molecule, apoptosis, etc., that really give a second life to the mitochondria from a slightly different angle. And I've studied that a lot, and I was privileged to be joined by junior faculty in my lab like Miguel Villa and Céline Perrier, who really were extremely instrumental in developing this theme in the lab, and who are now have their independent activity in Spain. And basically we have, like many others, have demonstrated how that can interconnect with the mitochondria. And from there, progressively also came along the discovery by a lot of our colleagues, breakthrough in the genetic of Parkinson's disease, with the demonstration that some of the gene product that upon mutation give rise to familial form of Parkinsonism happen to be either directly or indirectly associated to mitochondria, but maybe slightly different way now. And that it's specifically factors like DJ1, Parkin, PINK1, etc. And that led to I would say, a third life of the mitochondria in the field of Parkinson's disease. And that it's more from the angle of mitochondrial dynamics and mitochondrial autophagy or turnover. And so that's, I think, is the most recent probably trend in mitochondria, where I think that thanks to those rare genetic form of Parkinsonism, we may start to have a better idea how indeed mitochondria can play a role and bioenergetic can play a role in Parkinson's disease, but maybe through a slightly more complex and indirect way than what we have thought in maybe in '89 or in the '90s.
So it's no longer energy being the primary
Correct.
suspect, but maybe something else with the mitochondria.
Correct.
And you say, you hinted at your David Marsden lecture this meeting is going to be something about that?
Yes. So what I saw is that because, if you remember, the first time that I met David Marsden, thanks to you, was when I joined the faculty at Colombia in '91, and basically that David, from time to time, was visiting the group and spent time with us. And I think that I even think that, if I remember, that you asked David to meet with me and talk to me, etc. And at that time, I remember my first conversation with him was about mitochondria and what I was doing with MPTP and mitochondria, what I thought about this and where we were going, and because he knew about the group of mitochondria at Colombia, whether I thought that there could be also some associated features of other mitochondrial cytopathy, and we had all this discussion. And so I thought that, remembering that for my lecture, I thought that perhaps it would be appropriate to trace the history of mitochondria since the time that I met David up to now. And so it's basically going to be a journey through the mitochondrial story.
Sounds very interesting. Good. Well, I'm all eager to hear about it and your talk, and I won't ask you any more about it for this interview. But in addition to your lab work, you still are involved clinically as well. And I know you come to our clinic in our Tuesday afternoon Parkinson Movement Disorder Clinic, but you also do attending rounds and other
Absolutely.
things. So you have to juggle your life, don't you?
Absolutely, and it's really challenging. On one hand, I would not change it for the world. I think that that's one of the main, not the only, but one of the main reasons that I love so much the American system, is the ability really to do conjointly or concomitantly this clinical and basic science work. But it's true, it's challenging. It's challenging in part because, of course, keeping up with the clinical science together with the basic science is enormous. But I think that nonetheless, it's so exciting, it's so enriching that it's highly recommend for people who do not necessarily easy drop the ball or are not scared to have to read everything and anything. I think that this is really superb.
Well, it's great that you can keep that double interest going, and I know you've been very active with the Movement Disorder Society over the years too. You were in one of the congresses not too long ago, the program director.
That's right.
And now I recruited you for the World Parkinson Congress to chair the program committee and develop the next World Parkinson Congress, which will be in the same country of Canada,
That's right.
but in Montreal, another sister city, in 2013. So we're
That's
looking
right.
for a great program from you for that also.
Thank you.
So looking back, and let's say go back 20 years or more, if you had to change your life differently, would you pick a different route?
Well, I think that the only difference that I would have made, it's probably due to the fact that I'm privileged to, as you said, to be invited to be teaching, attending in neurology. I think that the only thing that I would probably change, I would do my MD PhD, formal MD PhD program in the States. Because I think that, and of course, it can only be colored from my own experience, because I know that in Europe, from where I'm coming, things have changed as well. And so there's no longer the way I've done it that now young people have to or can do. So I'm sure that now, if someone will start today, he or she can do a more American system-like of MD PhD integrated program. But at my time, that was not there. And you had to be creative and have the support of someone like Jerzy Hildebrand, for example, who loved this idea himself, have done both basic science and and clinical. And so he was respecting that and was promoting and even pushing us to do so. But you had to be creative. There was nothing in place for you to do that. And so it was easy to be forgotten or to not doing it. I think that in the United States, this is really, from my contact that I have with MD, PhD students, for example, I have graduate students from PhD and MD, PhD in my lab. This is such an exciting, sometimes I almost, as a joke, I said to my wife and my student, I would love to go back and do what you do. It seems so exciting, so great. And so the only thing I would change, if I could, would be to go to such a formal MD, PhD program.
Okay, well, you did get your PhD because
Right.
I know back to Belgium, you took the work that you did in our lab
That's right.
as a fellow and were able to turn it into a thesis and a
Right.
PhD. So that's good. So you do have both degrees anyway, but it came about separately
That's right.
and independently.
That's right.
Right. Okay, so let me ask a few other questions. They gave us some hints, and I want to make sure I didn't miss any of that. So you've already mentioned some of these role models. What about role models in the lab? You talked about some people in movement disorders. You mentioned myself and David, for example, and maybe you have some others.
Eva Gide, certainly
Yeah.
someone who played a key role. When I was resident, when I was even not, I was in medical student still, I was already attracted by movement disorder, not as clearly than today, but I was already, and we had the possibility to do rotations outside our system in Belgium. And I applied to do a rotation in La Salpêtrière in Paris, and Eva Gide was my basically resident, the French resident. So he just finished his agrégation at that time, was in '81, and so he was supervising the floor where I was as a student, and to me it was really a revelation to have a person like him seeing patient really at the forefront of seeing patient and all the time being able to mix with physiology and pharmacology and molecular biology and talking to the student and talking to the resident of the two aspects, the clinical and the basic science. I said, oh, this is great. That's really what I want to do. And so I think that Yves was really one of the first during this education that really gave me a tangible example of how you can do that. And again, particularly in movement disorder. So it was maybe less obvious or feasible in other disciplines. But in movement disorder, I thought that was.
So it was fortunate because he's involved in movement disorders.
Absolutely.
And he was your mentor or I guess he was a young faculty person
That's
at the
right.
time.
That's right.
La Salpêtrière when you got there.
That's right.
So that's good. What about other people like in the lab? I mean, you've obviously collaborated with others. And,
yes. So one person that always impressed me tremendously, and that was on my side all along since I started, often was there to advise me every time that I wanted and continue to give me advice. Short advice because he's very busy, but it's Solomon Snyder from Johns Hopkins. And so to me, when I start to work on MPTP, for example, or other aspect, because Sol Snyder really touched had a very eclectic career, I was always so impressed that not only the experiments were great, but when you read his paper, there was always a vision. And I remember that he did a paper that I read maybe 15 years after he published it, and he was right. He was right. What he was saying 15 years before, without knowing everything that I knew 15 years after, he was right on the mark. And to me, that it's really impressive. People that not only know how to run science, run a good experiment, write a good paper, but that have vision, that they can analyze critically data and try to make sense of the data, not to try to sell the data, like unfortunately often we all have the temptation to do, to make it more appealing to the reader, but really to bring vision. And I saw that Sol was fantastic, and over the years I think that he helped me tremendously, and with the little time that he had, give me wonderful advice.
Oh, that's interesting to hear. I didn't know too much about that in your career. So what do you think about challenges that you've had to meet and you've overcome? Well, let me go back before that, because I know you've also became interested, basically from your MPTP work, about the effect on mitochondria, how this might also affect, well, maybe ALS. I guess what it was is that the SOD1 gene mutation was discovered, and you started to wonder how that might affect Parkinson dopamine systems and so forth. You began to interface the ALS and Parkinson's.
Right. So for many years, and it's true, probably more than 15 years or even more, I began to wonder if, in fact, the different clinical expression of diseases, or phenotype, if you want, are in fact telling us more about specific systems that are affected by a disease than necessarily telling us that those diseases are caused by completely different mechanisms. And so what I mean by that is that I think that if we take the example of biology and evolution, I think that what we learn is, first of all, biology is very economical, and that evolution, if you find an efficient way to reach a specific goal, then nature is going to use this efficient way until nature finds an even better way to do it. But in the meantime, there is very little redundancy on doing the same function by multiple ways or pathways. And so I start to wonder whether it makes sense if you have, let's say, more than 100 different neurodegenerative disorders. Is it clear or even make sense to consider that then you will have more than 100 different pathways to kill, at the end, a neuron? And I said that maybe, no, that doesn't make sense. Maybe it is more likely to think that there is one or a finite number of highly conserved, efficient mechanism of killing cells. But there is a great multiplicity as to how the cell can connect, so what we call adapters. How the cell can connect and activate this same killing pathway. And so if that's the case, then probably the diversity of the phenotype reflect more the diversity of how you connect to the common pathway, rather than to think that you have very different pathways. And I begin to think about that, as often it happens, I think, in research, for maybe an interesting observation, but that was wrong. And that is that, if you remember, for years people have thought that maybe alteration in the superoxide dismutase metabolism could have something to do with Parkinson's disease. And in '92, it was discovered that mutation in superoxide dismutase could give rise to a form of ALS or Lou Gehrig's disease. And so I said to myself, here's one example of overlap. And I remember very vividly that another person that was thinking, and probably this person was thinking this way even way before me, was Dr. Rowland, our former chairman of neurology at Colombia, who was very interested, of course, in motor neuron disease, in ALS, and knew about my work, and came one day in my office early morning. He's an early person, I am an early person as well, and he said, "Serge, didn't you work on PD and SOD?" And I said, "Yes, Dr. Rowland, indeed." And he showed me the paper from Bob Brown and the consortium on ALS showing SOD, and he said, "I think you should work on ALS as well." And so I started to work on those two diseases after that, not so much from the angle of being particularly an ALS person, but more from the angle that this is finally maybe another disease that I can use to cross-reference the hypothesis that I had, that maybe all these diseases at some point or the other may have intersection in their molecular mechanism.
Okay, and so you continue to do both of these all the way. All right, one of the other thoughts that they suggested I talk to you about, have there been any biases or barriers in your way in your advancement through the ranks?
Not really. I think that the only thing that indeed has been a a little bit challenging, and I alluded a little bit on that before, is the fact that we have to recognize that even today, when you embark on a career profile of being a clinician scientist, first of all, you have to make sure that you're going to do that in a program that recognizes it and has a program that allow you to develop as such, to be educated as such, and to develop as such. Which, as I said, in the first part of my career, even if I was highly supported by several people in Europe, this type of program did not exist, and that was extremely challenging to do that. The second thing is that even when you are welcome in a program that recognize and foster and develop this type of people, you are really, or you remain really, a kind of extraterrestrial, because you're never being recognized or regarded by basic scientists as a basic scientist, but as a clinician. And by the clinicians, you're not a clinician, you're a basic scientist. And in fact, you continuously live in this kind of no man's land where you are an hybrid species, not really recognized or belonging to anyone. And it's fun, doesn't matter, but sometimes it's challenging.
Okay. Now, you have to balance your life at work. We already talked about the clinical and the basic, but also your life at home. And that's a challenge, too, for, I think,
this
for
is
any
a tremendous
academician.
challenge.
And how do you give enough time to your family? And I know you have 2 daughters and a
That's
wife,
right.
and you've been married ever since I've known you.
Absolutely.
To the same wife. And
Yes.
so you obviously had to make some balances there, too.
Absolutely. So I think that for me, I think that I have been extremely privileged in that sense to, first of all, as you said, to be married to my wife, and the same since you know me, and I was the only one. Because really, Sylvie comes from an academic family. I don't, but she does. And so she grew up with surrounded by a father who was an academician, wonderful man, who contributed, by the way, to create the chair of general practice or family practice in the university in Belgium. 2 brothers that are also in the academic field in medicine. So she knew exactly what was the problem. She's herself, it's a doctor in psychology with academic activities, so she knows that. And so I think that it's very important to, for me, it was crucial, in fact, to be able to count on the understanding and the patience of my spouse. The things I must say that over the year also helped tremendously is that with the, I would say, the internet and computer system, etc., I more and more begin to balance the activity. Because I think that for my kids, even if they see me working, the fact that I'm home, it's already good. It's not ideal, but it's already good. And so what I have tried to do over the years, first of all, is that to keep as short as possible my traveling. If I have to give a talk, I try to make it to go and come back home, to limit the number of days that I'm away from home. And then what I do is that I wake up early, go early to work, and try to basically do at work only what it's necessary to do at the office. And everything else I take in my bag, bring it home, have a small home office, and work from home. And so they know that I'm there, and I can continue my work. And so that's what I work, at least for me, for so many years.
Well, it seems to have been successful, so that's, I'm glad it worked out, and you figured it all out. Now, your involvement with Movement Disorder Society is obviously, you've involved with it. You've been, as I told before, the program chair of one of the congresses. You're now been elected as, and also now a member of the International Executive Committee. So you are recognized among the movement disorder leaders as well in the world, and so yet you must join other societies as well, Society of Neuroscience, I suspect, and so forth. So you have to also play roles with each of these societies, but specifically getting back to the Movement Disorder Society, how did you feel your relationship with the society over time?
So I think that my role with the Movement Disorder Society, of course, has changed over time. But I think that really it started almost from the beginning of the Movement Disorder Society. And I think that to me, the MDS really play a pivotal role and fulfilling what I think would be and was its mission. And that is that at the time, there was really an explosion of the movement disorder field. More and more young people were interested by movement disorder, by the phenomenology, by the basic science, by the clinical research. A lot of aspects that made movement disorder at that time a growing family, but a little bit everywhere and anywhere. And I think that to me, when the Movement Disorder Society and with the society, the journal, came along, I think that it has been such a strong force behind unifying, canalizing, standardizing, inspiring people who would be interested in movement disorder but did not necessarily know how to start and where to start. Basically, they really would have a platform and all the necessary tools thanks to the Movement Disorder Society, the Congress, and the journals. And so I think that really the Movement Disorder Society at the time that it was created, together with the journal, really fulfilled an immense mission that allowed our discipline to grow and mature the way we know it today. So for me, it was really I was interested in basic science of movement disorder, but I was still very much interested by movement disorder as a whole. And to me, coming to the movement disorder meetings and read the journal was exactly that, was to allow me to be connected and know exactly what was going on in the field and with everybody else. And then progressively, I was interested to give back to some extent what I have benefited so much from the Movement Disorder Society, and that is to progressively consider that it was time for me to give my time to them to continue in their mission. And that's what I have done through the Congress, where I was, as you said, chairing the program committee and other committee to try for the society to continue and to thrive in their mission.
And also the journal, because you were a member of the editorial board, and now aren't you associate editor?
That's right. And so under the new leadership of the editor of the journal, basically I'm one of the associate editor, mainly to try to promote even further. It was done already before, but there is a major push now to try to promote translational neuroscience, in other words, neuroscience that are directly applied to clinical questions and issues. And so by bringing someone like me, I think that as an associate editor, one of the ideas behind it was probably to try to push even further neurobiology of disease, since I'm also the senior editor for neurobiology of disease for Journal of Neuroscience. And so I think that all that could make sense indeed.
Okay. And if you had to select of your numerous contributions, so many, we're not going to name them all, but if you had to narrow it down to one or two of your major contributions, what do you think you'll be most remembered for?
Well, it's a tough one, because I don't think that I can say that I have made one single major contribution. I think that it's probably more, I was privileged to start in this field at a time that other colleagues of mine, such as Etienne Serges, Ted Dawson, and others of the same generation, really became aware or asked themselves the same questions. And I think it's really more kind of a movement than a specific research. I think that I've been part of bringing the molecular and cellular biology to movement disorder, but certainly not the sole, certainly not the unique, or certainly not the most important. I think that I simply tried to do my best and contribute the way I could by asking sometimes interesting questions that turn out to help us to move one step after the other closer for having an understanding of the neurobiology of disease. But I really think that whatever I've done also benefit from this contextual setting and these other wonderful colleagues that I had and continue to have, and who shared my idea and passion for neurobiology.
Okay, so do you have any advice to give young doctors entering the field? Let's say they come in, they want to be a movement disorder fellow, they're also thinking of the lab as part of their fellowship. What kind of advice would you give them today? Well,
I would say that exactly what you told me when I started, which is that, first of all, of course, if you want to go to being a clinician scientist, first you have to make sure that you have strong background in general clinical and basic science aspect, in whatever order, doesn't matter, but you have to have strong basis. And so they have, if they can benefit from an MD, PhD program or a strong PhD exposure or lab exposure together with a strong, I would say, hardcore clinical exposure, it's essential. And then go to a very demanding, if possible, the most demanding of all, movement disorder program, and really see as many patients during certainly the first year of your training that you can. I remember that you always told us that if it's to do movement disorder and do it halfway, you can read a book. Nowadays, all these books from great people in the field will describe everything we need to know absolutely outstandingly. That's not movement disorder. This is one aspect of movement disorder, but you have to see patients, and many, many, many patients. That's when you start to see and to feel the subtlety and be an expert in movement disorder rather than someone that knows movement disorder. And on that, you add research. I think that this mixture of being a clinician scientist is the most beautiful aspect of what an academician can do. And of course, I'm very much attracted by lab, wet lab, but clinical research, it's as fascinating and important. But what I'm saying is that being a clinician, love to see patient, love to spend time with your patient and teach your student, and try to invest your mind in analytical, investigative work as well.
Okay. All right. I think we'll wind down our interview. I enjoyed our chat together. I thought you came away with some very good thoughts for others and a good historical picture of yourself and where you think the field is blossoming, and I assume you think the field's going to continue to grow.
Oh, absolutely.
Otherwise you wouldn't be in it anymore, right? And
that's right.
So a lot more excitement to come than even in the past, right?
Oh, absolutely. I think that everything that we see, if the past few years are a guide of what's to come, I think that if anything, everything is accelerating rather than slowing.
Right. Okay. It was a pleasure.
Thank you, Stan.